Welcome to another lesson with Algebra. Our lesson today is the last section for Chapter 7, Solving Systems of Inequalities. In Chapter 6, we had discussed how to graph an inequality using two variables. And when we graph an inequality, the shaded region represents all the possible solutions. The solution to a system of inequalities consists of the ordered pairs that satisfy all the inequalities of the system. This set of points is the intersection, or the cross point, of the graphs of the inequalities in the system. So let's take a look at some examples here and see what this all means. When we graphed an equation like this, x is greater than or equal to -2. Remember way back from chapter 6, we go to -2, and it's supposed to be greater than or equal to that. So you go all the way across, and there is your graph of x is greater than or greater than or equal to -2. Then, if we had an equation that was x is less than or equal to 3, we would take, or go to 3 right here, and down to the left, and that gives us less than or equal to. Now, if we have two sets of inequalities, okay, we need to graph these. X is greater than or equal to -2, and x is less than or equal to 3. So first I'm going to go -2 right here, greater than or equal to, right? And then here is less than 3, less than or equal to 3. Now we have -2 there, 3, and it is everything in between. That's what this means, the intersection of those two. Now, systems of inequalities. When you graph an inequality, the shaded region represents all the possible solutions. The solution to a system of inequalities consists of the ordered pairs that satisfy all the inequalities of the system. So ordered pairs. Solving a system of inequalities. In order to do that, you're going to graph all the inequalities on the same set of axes. Find the solution set where the shaded regions intersect. Check your results. All right, in our first example, here we've got two equations, okay? We need to solve the system of inequalities. Let's solve for y, okay? Y is, if we set y greater than, we have to move the 3x over to the other side. You're going to subtract. So that's how we get -3x and then plus 4. And then here we have y, okay, x minus y is greater than or equal to 8, or less than or equal to 8. Because we need to take y by itself, okay? Y then, -y, is going to equal less than or equal to 8 minus x, or x minus 8. 8 minus x, okay? Then, because this is a -y, then I need to divide by 1, both sides by 1. And that's going to flip this inequality sign to be greater than or equal to, okay? And then my x, it was a -x over here. Now it becomes positive. This is a +8. Now it becomes a -8. So now I have both equations are y is less than the equation, and here y is greater than or equal to the equation. Sorry, this is y is greater than. both equations show us that y is greater than. So here in this equation, my y-intercept, if I set x at 0, y is going to equal to 4. So 0, 4, that's the y-intercept. The slope, remember our slope formula, y equals mx plus b? Well, look at what we have here. Y equals mx plus b. So that's actually the plus b right here, plus 4. That also gives us the y-intercept. But here we have negative 3x. Remember, mx. So m is negative 3. So negative 3 times x. That's our slope, negative 3. Shade above dashed line. So if we were to now graph this equation, we can easily plot 0, 4. And then remember the slope is the rise over the run. So negative 3 going down over the run, the slope. But in this equation, it's negative 3. Okay? Here, y is greater than or equal to x minus 8. So this minus 8 here is already the y-intercept. Okay? So 0, negative 8 is where this equation crosses the y-axis. Then my slope, I'm going to take a look here. mx plus b, right? mx. Is there anything in front of the x? It's a 1. So then this is y equals 1x minus 8. Or y is greater than or equal to. And your slope is 1. And then you want to shade above the solid line. Now, why is this a dashed line and this is a solid line? Because this is just greater than. So greater than or less than would be your dashed line. The equal sign, even though it's greater than or equal to, you have a solid line. So now we take our lines and we graph them. So earlier we had the intercept, sorry about this, the y-intercept here was 0, 4. And then the slope of negative 3. Okay, so remember these. The other equation, the y-intercept was negative 8 with a slope of 1. So here in our graph, y equals negative 8. And then here for this first equation, y equals 2, 3, or 1, 2, 3, 4. Y is your intercept is 4. So the red line is for this first equation. The blue line is for this second equation. All right, now with example 2, let's take a look at this. We've got two different inequalities. X is greater than 0 and y is greater than 0. Then we also have 2x minus y is greater than 1. Okay, so when you graph x is greater than 0, you shade to the right of the dashed line. X equals 0. So at 0, you're going to shade everything up to the right of x, or everything to the right, on the right-hand side of your graph. When y is equal to 0, or y is equal to 0, you shade y is greater than 0. You shade above the dashed line. So imagine this is your x-axis, and then here's your y-axis, okay? So x is greater than 0, that's everything here, to the right of the origin, 0, that was your x. Then everything above 0 here is your y. The first two inequalities limit our solutions to the first quadrant. Okay, here is your first quadrant. Okay, now graph the third inequality. So the third equation was 2x minus y is greater than 1. So I'm going to solve for y, and we end up flipping that greater than sign again, because you would have had a negative 1 right here and had to divide by negative 1. So we have 2x minus 1 for our equation. And the y-intercept now, okay, y equals mx, the slope times x, plus b, and it's negative 1 here. So this is going to be 0, negative 1. M equals the slope is equal to the 2 coefficient right before the x. So we shade below the dashed line. So at negative 1 on the y-axis, everything below that is what this graph would look like. Shade below the dashed line. Sometimes we are given the graph and we can write the system of inequalities which it represents. By finding, or begin by finding, the equations of the boundary lines. Okay, the orange line is horizontal. Okay, in your book, you have on page 320, and here's example number 3. Okay, it says, write the system of inequalities represented by the graph. So first they give us the y-intercept is at negative 4. So if we had a graph here, we'd go down to negative 4 on the y-axis, okay? Since the line is solid and the shading is above it. So here, this was equals, okay? But now we're changing that equal sign to greater than or equal to negative 4. So that means all of your y is going to be above negative 4. All right, in our next example here, okay, there we go. The blue line, okay, example number 3, okay, if you take a look on page 320, example 3, okay, we've got a blue line and a red line. So the blue line is with this equation, y equals negative 3x plus 1. This blue line has a slope. Slope is our m, right? This would be mx plus b. So m is negative 3. The slope is negative 3. It's going to lean toward the negative side of your graph. Okay, since the line is solid, the shading is below that. So underneath the line that these 2 points give us. But then we set it to an inequality, and so we have y equal, or is less than or equal to negative 3x plus 1. All right, now here's your homework for this section, and I'm sure we will see each other again in discussing the homework problems. Thank you.